Potassium permanganate is the most important and well-known salt of permanganic acid. It is prepared by fusing pyrolusite ore or manganese dioxide with caustic potash or potassium carbonate in the presence of atmospheric oxygen or any other oxidizing agent like potassium nitrate. The reaction produces dark green potassium manganate, which disproportionates in a neutral or acidic solution to give potassium permanganate. In the laboratory, potassium permanganate is prepared by the oxidation of a manganese 2 salt by peroxodisulfate. Industrially, it is prepared by the electrolytic oxidation of a manganate solution. In this method, the manganate solution is placed in an electrolytic cell provided with a rotating wire netting anode. An inlet pipe made of iron for the liquor acts as the cathode. The oxygen liberated at the anode converts manganate into permanganate. The purple solution containing potassium permanganate is evaporated under controlled conditions. Potassium permanganate then crystallizes out. Let us now look at the properties of potassium permanganate. Potassium permanganate forms dark purple, anhydrous, needle-like crystals that are isostructural with potassium perchlorate. It is moderately soluble in water. On heating strongly, it decomposes into potassium manganate, manganese dioxide, and oxygen according to the equation shown here. The structures of the manganate and permanganate ions are shown here. Both these ions are tetrahedral. Pi bonds are formed by the overlap of the p orbitals of oxygen with the d orbitals of manganese. Note that while the manganate ion is paramagnetic due to the presence of one unpaired electron, the permanganate ion is diamagnetic. Let's now look at the chemical properties of this compound. Potassium permanganate acts as a powerful oxidizing agent in acidic, alkaline, and neutral solutions. The effective equations in each of these media are given here. Let us see some important oxidizing reactions of this compound in each of these media. In an acidic medium, it oxidizes sulfides or hydrogen sulfide to sulfur, sulfur dioxide to sulfuric acid, sulfides to sulfates, nitrides to nitrates, arsenides to arsenates, oxalates or oxalic acid to carbon dioxide. Ferrous salts to ferric salts, iodides to iodine, hydrogen peroxide to water and oxygen. In a neutral or fairly alkaline medium, it oxidizes manganese sulfate to manganese dioxide in the presence of zinc sulfate or zinc oxide as catalyst, potassium iodide to potassium iodate, sodium thiosulfate to sodium sulfate, nitrotoluene to nitrobenzoic acid, Let's now study the uses of potassium permanganate. Alkaline potassium permanganate is used in organic chemistry under the name of Bayer's reagent. Apart from being used as an oxidizing agent in the laboratory, it is also used in the volumetric estimation of ferrous salts, oxalic acid or oxalates, and hydrogen peroxide. Qualitative analysis for the detection of halides, bleaching of wool, cotton, silk and other textile fibers, decolorization of oils.